So we can begin with the one identity involving both the tangent and the cosine x directly or indirectly. So actually, when we use this Pythagorean identity, we have the secant square x equals to 1 plus tangent square x, right? And then we can use the reciprocal identity to write this secant square x as the 1 over the cosine square x. So 1 over the cosine square x is equal to 1 plus tangent square x. And then we flip the both sides, then we get the cosine square x is equal to 1 over the 1 plus the tangent square x. So actually, we multiply both sides by the cosine square x and divide both sides by 1 plus the tangent square x, right? And then we get the cosine square x equal to 1 over this 1 plus tangent square x. Now, you take the square root of both sides, then you get the cosine x equal to plus minus 1 over the square root of 1 plus tangent square x. Now let's look at the problem 26. And in this 26, use identities to find the exact values at alpha for the remaining 5 trigonometric functions. So you need to notice exact values, okay, not approximate. So in the 26, we know the secant alpha is equal to negative 4 times the square root of 5 over 5. And alpha is in the quadrant 2. So now we need to find the value of the other 5 trigonometric functions at alpha. Since we know the secant alpha equal to negative 4 times root of 5 over 5, right? Then the easiest to get is which one? Cosine, right? So the easiest to get is the cosine alpha, which is equal to 1 over the secant alpha. So you have the negative 4 times root of 5 over 5 as denominator. And then to simplify this complex fraction, you multiply both the numerator and denominator by 5. You cancel this 5 and this 5. And then you get negative 5 over the 4 times root of 5. Right. Now you rationalize this fraction by multiplying both the numerator and denominator by root of 5. And then let me turn here negative. So 5 times root of 5. And then the square of the root of 5 is equal to 5. Right. You have the 4 times 5. And this 5 and this 5 cancel. So finally, you get negative root of 5 over 4. And this is the cosine alpha. Now, after we find the cosine alpha, which is next? Which one? which one is the easiest to get for the next step? Sine, right? Okay, let's get the sine. So we have the sine alpha equal to plus minus the square root of the 1 minus the cosine square alpha. But we know in the problem it says alpha is in the quadrant 2. Let me use the symbol belongs to the quadrant 2. Okay, this means alpha is in the quadrant 2, belongs to this quadrant. So in the quadrant 2, tell me what is the sign of the sine alpha? Positive, right? In the quadrant 2, sine alpha is positive. So from this, okay, so since alpha is in the quadrant 2, so sine alpha is positive, then we just get sine alpha is equal to the square root of 1 minus the cosine square alpha, right? Now let's plug in the values. Okay, to plug in the value of this cosine alpha into this expression, then you get the square root of 1 minus the square of the negative root of 5 over 4. And then you simplify, you get the square root of the 1 minus, okay, this is the 5 over the 16, right? And then let me turn to here, square root of 16 minus the 5, minus 5, and over the 16, then you get square root of 11 over 16. So this is equal to the square root of 11 over 4. Okay. So by now we have found the sine alpha, cosine alpha. Then the other three are easy to get, right? When we just use the identities from the definitions. Okay, let's go to a new page. So now tangent alpha is equal to sine alpha over the cosine alpha. And this is equal to root of 11 over 4 divided by negative root of 5 over 4, right? And this 4 and this 4 cancel, so you get the negative root of 11 over root of 5. So actually we just multiply both the numerator and denominator by 4, right? And then we rationalize this fraction by multiplying both the numerator and denominator by root of 5. And then the denominator becomes 5. The numerator, by using the product rule for the radicals, we can first multiply the radicands and then take the square root, right? So you have the 5 times 11, you have the 55. Okay, so this is the tangent alpha.